welcome back to the crash course. This is session 2 of 3. It's actually is it a third crash course? Yeah, I guess so. Wow, time flies. And in this crash course, we're going to be building an LED matrix that can scale up and down using these reusable sublayouts. And so I'm just going to recap session 1 briefly. Hopefully everyone was able to see the recording, which I tried to share as quickly as I could right after the session. And that's kind of nice because you can follow along, pause, sort of take it in at your own pace. So feel free to catch that. That's on our YouTube channel. And then we're just going to get started with the demo. And today we're going to be building a sub layout. We'll be routing it, and then you're going to learn more about how to use portals, which are kind of like net labels, which Jarm will talk about very shortly. So we're going to finish that, and then we'll have a Q&A session. Feel free to stick around and hang out. We're going to be here for roughly an hour and a half. We'll stick around for 30 minutes or even longer. And that's a really good time to utilize if you have questions with your own projects, whether they're related to the demo that we give or just like your own personal projects. That's just time that we want to spend with you one-on-one, help you troubleshoot, answer questions wherever it might be. So just so you remember, our goal here is to build an LED matrix in Flux using sublayouts. And it's an important concept to understand with Flux because it allows you to reuse portions of your PCB very quickly and not have to rebuild these parts or lay them out again. That's really cool. So you have one path where you can use the reference design, kind of follow along with us. And then you have another path where you can build your own projects. And many of you are already taking that on. So it's the second session, like I said. I already covered what we're doing today. So next Friday, we're going to be routing the PCB, the final project PCB, using those sub layouts. And then we're going to show you how to export the Gerber files, check your project for manufacturability, and you'll actually be able to order, this project. So we're also financing the first run of either your project or this project because we're looking for feedback on the whole manufacturing process to actually receiving your board. So just FYI, if you have your own projects and you want to get them built, now is the time if you need the motivation. Woohoo! Yeah. So what did we learn in session 1? We learned the power of rules and how they're a little bit different than DRCs that you might have used in the past. They happen, they allow you to make changes to many components at once using our selector rules. And those changes apply in real time. So not at the end of a process. So this can actually speed up your PCB design significantly. And we had a relatively simple example, which is just how to take 16 LEDs and position them pretty quickly into this matrix that you see there. So I really encourage you to watch that video. If you have questions, feel free to reach out on our Slack here. We're here for you. So what are we going to learn today? Well, we're going to learn these 2 things here. So first, we're going to learn how to use portals to clean up your schematic, similar to net labels. And portals are pretty powerful. They actually work with simulation, with the PCB editor. So they're also, they're functional. They're not just for show. The second thing we're going to learn here is how to route the LED matrix that we built and turn it into a sub layout that we can reuse. And we're going to use this sub layout in the next session and put it all together and, basically make the biggest LED matrix array that you want. So it's kind of a way to scale up this maybe you're going to make a giant TV screen. Obviously, it's limited by the capacity of your microcontroller that you're using, but hopefully you understand these principles and you can take them away and use them on your own projects. That's really the real objective here. So with that, I'm going to hand it over to Jarwin to begin the demo.
Yeah. Yeah, thanks, Lance. So yeah, let me try to share my screen here. Okay, here. Okay, just tell me if you can see my screen now.
Looks good.
All right, so yeah. So just to recap, on the last session, we actually like reposition these 16 LEDs using rules on the PCB here. As you can see here, these are the rules that we have created, selector base rule, and they are like, space out precisely, space out together, align, etc. So what we're going to do now is actually like route this this project here. So using portal and also tracing the PCBs. But before that, let me share you the link. So for anyone who wanted to follow along, you can fork that project that I just sent over to the Slack on the Zoom chat. To actually like clone this project, just go here in the Flux drop down menu here on the top left, and then clone the project, and basically you'll have your own versions, and so that you can follow along. Okay, so this just also to for someone that is like just we're building this particular project in here. So the project that is like composed of 16 LEDs is just actually this area here, which is like, let me zoom into the schematic diagram. It's here from D0 to D3, and then from GFED, this area here. But because we could utilize the sub layout, we could do that one just by the 4x4, and then we could scale it up like 4 times so that we could put this 64 LEDs. So yeah, we're going to start from here. And okay, let's say if I could, let me clone this project because everyone's already in here, just to make sure that the performance will not be affected here. So let me try to actually clone the project, and it will create a new document on my account. Okay, so yeah, let's just wait for this one to be cloned, and then we could start. We're going to focus on the net portals for here. So yeah, so the old way of actually like wiring this up together is using wire. This is still valid, but it actually like give you like limitation, wherein what if you want to actually drag the 4 LEDs somewhere else on your schematic, you cannot do that one because it's connected literally with wires. And sometimes you cannot avoid these crossing wires in here, which also like they're not connected, but yeah, it creates a lot of confusion. So we're not going to do this one today. We're going to use the net portal. Okay, so let's go here. Let me close that other project. So yeah, the net portal is located here on the part library. It's on the third the third on the list. So I'm going to drag one in here. Okay, and by default, the net portal doesn't have any designator. If I'm going to open this up here, it's empty. So you have to put a name into it. It's almost like net labels on other tools. You need to actually like put a name, and the other portal should also have the same name so that they could considered connected. So yeah, I'm going to drag these 4 LEDs here to make some space. And then I'm going to name this one, what is that? D0. D0 for the cathode side here. D0. Okay. So I'm going to put a name D0. And then I'm going to copy, then paste it over here. I'm just going to leave the other one here on the right side. And now I have this D0 here. Okay. I'm going to reach the other LED4. 1, going to connect here and here. Okay. And as you can see here, if I select D0 on the canvas, it shows me where at exact points or, connections here in the PCB. I mean, on the schematics, you can see as soon as I highlight this one, it shows it's connected on this cathode side of this LED 1 up to 4. Okay, so that's clear. So, and by the way, you can create your own portal. You could create whatever portal you have. Like, let's say, for example, you don't like this line, you could actually create a part. Okay, create a part. The only requirements that is needed to make the portal work as a portal is actually setting the part type. Portal here, and just add these two properties here, which is like it will exclude the portal on the bill of material, and also it wouldn't show anything on the PCB because it's just actually like representation of connection on the schematic. I'm going to copy this one again, paste it here, and if we go back here on the schematic diagram, the area here is connected to this letter G. Okay, so I'm going to go here, name it G. Okay, and I'm going to connect that here, and the other line is FED. Okay, so I'm going to copy this one 3 times. 1, 2, 3, and I'm going to just name this one F E, and this one D. Okay, I'm going to put them here. Okay. Now, as you can see here, we have one portal here, which is D0. Copy this and as you can see, if I select G, hit highlight where it's connected. It's here. F there, E there, and D it's here. Okay. And as you can see here, if I select D, you see that it's connected to the cathode of LED 1, 2, 3, and 4. If you go PCB, it creates that air wire. As you can see, that one to connected here to here to here. Okay. All right. So D0. What's next? D1, D2, D3. I'm going to this one quickly here. Go to copy and then name this one D1. Drag it here. And the moment I connected it to LED number 8, we could see that, no, not yet. Okay, connect it in here, here, and here. Going to do the same thing again to this row number 3 and row number 4. Place it here, here. Going to do this one here, like, oops. Yeah. And then afterwards, I'm going to name this one D2, and this one is D3. Okay. Because I have D0, D1, D2, D3, I'm going to copy this one 3 times, or maybe just copy this one here and paste it here. So that's D1. Okay. As you can see here, if I select D1, that's for the second row. so on and so forth. Okay, I'm going to do the same thing on the anode side, which I'm just going to copy this 4 and paste it here. Connect it here, connect it here, and here. Okay, going to copy that again and connect them here. Okay, we're almost there, guys. Okay, GFED, going to copy it again here.
And feel free to chime in if you have any questions about what Jarwin's doing.
Yep.
Either
Okay.
can-
Yeah, sorry, Lance.
I was just saying you can use the Zoom chat, or you can just unmute yourself and shout your question aggressively at Jarwin.
Yeah, so as you can see here, if I select the portal D here on the left side, it highlight that it's connected to the anode side of those 4, 8, 12, 16 LEDs. That's also the same with E, F, G. You're most of you are already familiar with this one because it's currently exists on other tools also. But yeah, there's actually like a visual highlighter in here so that you don't need to actually think, oh, where's this connected? You know. So, and by the way, guys, our net portal in Flux is actually also work on simulation. I totally forgot that one. So let me open this other tab in here. Okay, and as you can see, it's simulated. So this circuit has a waveform generator here on the left side that is like producing positive and then, you know, negative 5 volts. And the other here is just a normal DC supply that is like stable 5 volts. And as you can see, if I select here, it's connected to these 2 points here. That's why you can see that the LED is blinking because it's outputting what is that? A square wave. See that? And the other one is because it's just a DC supply. Yeah, it's steady LED. So yeah, the net portal also work on simulation. Okay, so we're here. Actually, we're almost done creating the schematic in here. What I wanted to actually like tackle here is like it to the terminal. Okay, why is it that need to add a terminal? So
Hey, Jarwin, quick question.
yep.
From John, he said, why is there a little jog in the E and F lines above diodes? Is he talking about the symbol?
Here? Where is it? This one here, the
I
connection.
think he's asking why the line isn't straight.
Yeah, because sometimes, you know, it doesn't.
I've got an answer for you because we got beta in the name right now.
Yeah, there's a snapping guide that helps get it aligned, but Jarwin's is moving quick.
Yeah, and also sometimes, you know, when you are very zoom out, just like what I, you know, when I actually wired this schematic diagram, I was totally zoom out, and sometimes, you know, the snapping is no longer that kind of, you know, very refined. That's why, you know, those are like created. But yeah, if you can actually create your wire at this zoom level, yeah, pretty much like as you can see here, as soon as I'm aligned to that diode, it snap, and there you go. It's a straight line. Yeah. Okay. So why I need the terminal in here? Basically, if you look at a resistor here, okay, this is a resistor. Resistor contains 2 pins, right? The P1, the P2. It's represented by a terminal. And then once you publish this, the resistor would have 2 connections, right? Now, because we're building a, you know, a sub layout here, we need to add 8 terminals so that when we are going to use this 4x4 matrix, we have 4 termination points. I mean 8 pin. We could actually do that one here. Okay, I'm not going to add any terminal for the meantime. I'm going to publish this. And by the way, before I forgot, before you publish your project, if you wanted to share that to the entire community, you need to actually like set the permission to be like not private. Maybe anyone can comment, anyone can edit, something like that. So I'm going to here, and then if I'm going to publish this, it will be already available on the part library. But because I did not add terminal, let us try to create a document here, a blank document. Good. So we have a blank document here, and we're going to search for that part. What is the name of that? 4x4 matrix 1 TQMG. TQMG. By the way, maybe I need to refresh. Let me close this browser here. TQMG. Okay, it's here. As soon as I drag this, you would see that it will be just a box. Okay, wait for it. Okay, it's here. So you can see it's just a box. There's no connection. You cannot use this because, you know, if we go back again here, we don't have any terminal yet. You know, that is why we need to add the terminal. Okay, going to add the terminal here, and I'm going to name it the same thing with the net portal that is like, you know, D0. Okay, going to name this one D0. Connect it on that portal. So basically, if every time you're going to use this sub layout and then you connect something on D0, it's considered connected to this portal inside this document. So I'm going to publish it again. That terminal. Publish. On the other side, as you can see, there's an update that is like available for this part. Okay, I'm going to review. Okay, I added the terminal. Okay, let's accept that update. And as you can see, the D0 appears here. I hope that is like makes sense why we need a terminal. I'm going to copy this one again like 8 times, right? And name it D1, D2, D3, and then GFED. D2, this one is like D3, and then I'm going to just copy that 3 terminal and just paste it here, and okay, there's more. Another one.
I was just going to add, Jarwin, I like the way you explain terminals as like a window to the outside world. So for any part that you're building, sub layout, module, just needs to have terminals so you can use it in the outside world.
Yeah, that's basically like, you know, their purpose. So here I have P5, P6, P7, P8. So I'm going to name them so that they're going to appear, you know. So let's say I did not change P5, P6, P7, P8. Going to publish it again, added more terminal so that for anyone, you know, using this part, you know, what is the update? So they have a context, what have been done, you know. So added more terminals, publish. And then on the other side, where the sub layout is being used, I guess I could actually the part update again, added more terminals. Okay, update that. And as you can see, we have those terminals already added. But then, you know, we need to change the P5, P6, P7, P8 so that, yeah, it makes sense where is P5 is connected. So in this case here, I'm just going to name this one G F, E, and D. Okay. Okay, and that's it. We're going to publish this one again. Okay. Maybe like, added, well, I mean, rename the terminal. Okay, publish. And then on the consuming side, they're going to get that also. You could also like, on the part updates, if you don't want to actually like clicking on the update, you could actually like, opt in to receive the latest drop. So every time I change something on the main sub layout, I don't need to click the update. It always get the update in real time. Okay, so that's it. That's for the parts update. Okay, so we're almost like done on the schematic. I mean, this is already done. If we can go back in here, D0, D1, D2, D3, it's connected to the cathode of, okay, and then GFED. Okay, so that's it, So let's go to the PCB where we're going to route this, the PCB of this sub layout. So okay. So every time you add terminal to the canvas, because you need that one, as the window to the outside world, your access to this inner sub layout, every time you add the terminal, there would be a pad represented by that terminal on the PCB. As you can see here, I'm going to drag this one. Okay, that's like D. This one is D0. And as you can see, air wires let you know where it's connected. See that? So let me drag in here. So depending on how many terminals you have on the schematic, that's also represented by this, 8-circle pad. So I want to change them into a rectangular pad, but I'm going to use again the selector based rule. Okay, so I'm going to create a new rule. Going to name this one from D0 to D1. It's up to you, whatever the name. Oh no, D3. Then I'm going to use the selector syntax to select those pads. So £, D0, comma. What is that? What is it that I cannot? Okay, I'm just going to copy this here. Okay, as you can see, if I hover here, or I mean, I select, every time I select the selector base input text box, you're going to see that where are those pads, that that is like selected using this selector, using this syntax. Let me hide the grid so that is like clear. Okay, I'm going to highlight, see, those are the D0, D1, D2, D3. I'm going to change them, the pad shape at once. So I'm going to add a rule. Going to call the pad shape. Okay, and then because the default is circular and I want a rectangular, so basically just, selecting the pad shape and go with rectangular. See that? And because I want it to be like rectangular, not a square, I'm going to add another rule that is like size. Okay, so we have pad shape and size. So the size will be like, what is that? Maybe much more smaller, 0.5. Yeah, I guess that's I'm okay with that already. Okay, so we have already controlled D0 to D3 pads using the selector base rule. I'm going to do the same thing again for the GFED terminal. Okay, so I created a new rule. This one is like GFED pads. And just pasting it here. As you can see, pound key G, comma, pound key F, etc. And it shows here where are those pads. Okay, I'm going to Or maybe like instead of creating a new one, let me just duplicate this one because I want it to be like the same rectangular and the size. Okay, going to just name this one GFED, and then paste this here. There you go. You just copied the pad shape and size. So now we're going to reposition these pads here because this pad will be the connections later on the consuming side. Once you consume this sub layout, this is where you're going to connect that terminal. You see here on this sub layout. So this is the sub layout that we're building in here. See that in here. So every time you connect something in here on the E pin, that means to say it's connected. Where's that E? In here. Okay, maybe I need to select the objects and go and find E. So it's here. This is E. So every time you connect something in E, should be connected here. Hopefully that is like makes sense. So going to reposition this now. Okay, so one here. Okay. D0. Let me go back to the schematic. Okay, D0 GFED. Okay, it should be on the top. G should be here. Should be here. F. Where's that F? Okay, it's here. Okay, and then E. E and D. There's D. Should be here. And then this one is D0. Should be here. D1 is here. And D2, it should be here. And D3 should be here. Okay. Now, I could actually like eyeball this if it's aligned, but I could utilize the rules again in here. So from D0, I guess this one is D0, this is D1. Okay, so I'm going to tackle this one here, this role, this selector base role in here. And I'm going to add an X position, and let's try to just play around with the value here, maybe like 16 millimeter. Oh, where's that? Okay, it's very far away. Maybe it's like 8. Okay, we're almost there. Maybe 7. So yeah, that's it for the group of pads. The other one is here for the GFED. Okay, going to add, instead of X position, I'm going to add the Y position, and then should be 7 also. Oh, maybe 7.5. Yeah. Then maybe like I just need to put in here, and this one should be in here. Okay. Then yeah, we're almost like done. And the next thing that we're going to do is like trace this PCB. But before I'm going to, let me actually like refresh my browser, because Flux is still in beta. So sometimes I usually like refresh my browser every time I do something like that, those kind of actions. So from here you could already see that there's already an air wire. The pads are already repositioned to where they should be. So the next thing that I'm going to do here is like on this. Okay, I'm going to make sure that the layout is like set to 16 millimeter. Okay, so yeah, so let's start routing, because routing on the PCB, it's almost the same thing on the schematic diagram. On the schematic diagram, every time you hover to a part, there's like a dot, a circle, where you connect the wire. It's almost the same thing here on the PCB, So when you hover to this LED one in here, you can see there's that there. There's another dot in here. Just click on that, okay? Click on that, and as you can see, it create a projected trace where this, where this pad should be connected. As you can see, it can be connected here, could be connected there, or here, or there. See that? And then, as you can see also, it create that 45-degree jumper. You could also create, just a straight vertical. If you go like that, it's snap. If you need a 45-degree jumper, just go right side and just move your mouse. And then let's say you don't want that particular kind of angle. Just press F, and that would actually like flip the trace. The same thing, it's available on the schematic. You press F, it does this thing. Okay. So yeah, let me just connect this here quickly. Connected. Okay. And if you go here on the nets, these are the nets that we have currently on this schematic. And the moment I create a trace, you can see here, it created trace. See that? That is like created because you route the air wire. And every time you complete an air wire, as long as you actually connect the needed connection, the air wire will vanish. So air wire will be like your what do you call that, source of completeness. If you don't have anything, if you don't have any air wires anymore on the PCB, that means to say you already routed the board 100%. But in case, you wanted to hide the air wire because you want to focus on the placement of component, etc., you can hide the air wire by actually going in here and click here. And yeah, they'll just disappear. Okay. Let me complete this board quickly in here. So I'm going to click here. Okay. I'm going to do something like, later on after I connect these pads here. Okay. Maybe you're going to ask me, oh, how do I move to the next layer? Oh, why is it that there's a bug? Okay, let me refresh, guys. By the way, if you have any question, just send over a question to the chat here on Zoom. Okay, going to click here. Oh, why is it that? Okay. 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 Oh. Oh, there's something wrong on this area here. Why I cannot route this? Good question. What is the definition of nets? Nets is actually okay. So Brian Paul, quick question here. So a quick question from Brian. What is the definition of net? The net is actually like the name of the connection that is represented in here. So if you look at here, this wire here, and where this LED 5, 6, 7, 8 is connected, this is considered one net. You could actually verify that if you actually just select one segment, and every connected net will show in blue. I am not sure if that is like the question that you were that you're expecting, but maybe like Nico could actually like say something about that.
No, you answered my question. Basically, nets is a synonym for connection, and that each particular net has some sort of a way of identifying it. So that makes sense to me.
Okay. Yeah. Great. Okay. Yep. Okay. Let's go here and let's see what is the problem here. Why I cannot route this? Okay. Okay. What is that? Row number 3. Row number 3 should be here. Okay, let
Jarwin,
me
I can, yeah, why don't you figure that out and I'll just pontificate a little bit on nets. What's up, guys? Brooks here, product designer at Flux. Hey, I just wanted to mention a little detail about nets and the portals that we shipped. This particular Flux. The name of your net can be different from the name of your portal. Okay, it's a little weird. It's a quirk about how we've implemented portals right now. If you look, actually, yeah, you can see the net list there. The nets have these crazy random names. You can rename those. You should probably rename them to be the same thing as your portals, but you don't have to. You can do anything you want. So yeah, just a little heads up there. It's a little gotcha. And you know, hey, shit dog, let you know a little secret. You know, we implemented these portals the way that we have them as part of a hackathon project. It's just something to do really quick to unblock people. I think down the line, we really want to have portals. We really want to have nets that are named the same thing be automatically connected, right? Like we've seen that in some other software. What is it? SnapEDA is doing that. I think actually a bunch of folks do it this way. It's going to be really easy in the future. Yay. We're not there yet. So bear with us while we do portals in this way. At least we're unblocking folks so you don't have to like draw all these wires all over the place. Okay, that's it for me. Thanks.
Yeah, thanks, Brooks. So the issue was like, if you remember, when I actually connected this area here, the third row, I was very, very quick that, maybe the app wasn't able to capture those actions. So this particular net here was registered, but somehow, it doesn't let me create a trace. So what I just did is actually like delete this internet and then reroute it again, and that's when I was able to route this on this connection here. Okay, so and I guess it's up to this area here. Okay, there's a thing that we're still working on that maybe like a gotcha, just like what Brooks has I've mentioned. So this pad here needs to be connected here or here, or here, so you could actually like create a trace from here, then going down, right, and click here, and then after that's like created, your expectation would be like click here and connect along the trace that is like already been drawn. But that's not the case. This is still work in progress, where you could actually like connect at any point along the trace. But right now, it's not yet in production. So okay, so what I'm going to do here,
can I just say I'm so embarrassed that it's like this, but welcome to the beta. We're living on the fly. Like in a couple weeks, we're hoping that we will enable the feature where you can just start a route and connect to anywhere on an existing route. Today, you can't. You have to go to these vertices, right, at the endpoints of these segments. So that's just a little gotcha right now. Thanks for calling that out, Jarwin. Sorry, everybody, pardon our dust.
Yep. Yeah. So okay. So I'm going to delete this already drawn trace. Okay. So I'm going to go here on the objects, and then I'm going to select the trace, and let's see where's that trace here. Okay. This is like here. Yeah, this one here. So I'm just going to click here, press shift, then delete. Okay. So that's already been deleted. My workaround for this particular problem, it's not really a problem, but it's like this. Going to click here, okay, and then click here, and then where this pad needs to be connected, I'm going to click on that to create a vertex, going to click on that, and as you can see, the air wire stayed at where it's, I click on that area. Going to do it here, going to click, there you go. And here, I'm just going to just go here and click, maybe like, just a small jumper, click. Now, I could literally just click here, click there, click here, click there. Yeah, hopefully that is like, makes sense for now, but yeah, the solution will be like out in weeks, in weeks time. So yeah, that's done. The next thing that we're going to do is this one here. And now this is where I'm going to demonstrate how you could traverse the inner layer of a board, because basically a board could have like a 4-layer. As you can see here right now, it contains top copper, mid layer 1, 2, and bottom copper. So this board composed of 4-layer, because remember here on the layout, I actually added the stack up rule, but I disabled it for the sake of demonstration. I could actually just, check this, and the moment I checked on that, you see the mid layer 1 and mid layer 2 disappear. I'm going to uncheck it so that I could demonstrate this kind of, traverse when you're routing. Okay, so this pad here needs to be connected in here, but I cannot do that one because there's an existing trace here that is like running across here. So I cannot go, here, because there is like, it will create a short. So on other tools, you create a via, then go on the other side of the board, right? In Flux, you do it like this. So let's say I want to go, just select a position anywhere on the canvas, like here. This is the safest place. I'm going to just right click my mouse while the routing is still active. Going to right click, and as you can see, I have like an option. Okay, where do you want to go? Mid layer 1, 2, or the bottom copper? I could literally do it like this, So now I'm on the middle layer. Okay. And let's say you want to traverse again the mid layer 2. Just right click here and go here mid layer 2. And while doing that, it create the via for you. You don't have to create a via and then connect things, So from here, let me go to like bottom copper, and then from here, let me go back to the top copper, then connect. And that's basically like it's connected, but again, there's a bug in there. Okay, it should create another layer here, a bottom copper. Let me see, maybe it's hidden. No, it's not hidden. So yeah, that's how you do it. But for the sake of, this is a sub layout that is like could be done in just a 2-layer board. So I'm going to delete what I just did here. Okay, let me try to find where's that. Okay, it's here. I'm going to delete everything.
Jarwin, real
Okay.
quick, can you remind me what you did while you were drawing the trace in order to transition layers? Did you right click or something, and that's what gave you the layer selection menu?
Yeah. Basically, while the routing is active, you just right click. You just see here, to right click, and that's where this menu will appear that you could select. Yeah.
That's very nice. I really like that.
Yeah. So yeah, as you can see here, I could select mid layer 1, 2, and bottom copper. But this, as I said again, you could route this board using just 2-layer board. So I'm going to click here on the layout, and I'm going to activate the stack up rule that is like set to 2-layer. But yeah, you could definitely go crazy and pick 8-layer, 10, or 12, or whatever. But for now, this would be like just 2-layer. And now, as soon as I activate this one here, okay, going to just route this one here, go to the bottom copper, and then go here. I'm going to create a vertex, click, okay, and then go again here, going to click, and then here, I'm going to create a via to the top copper, okay, and click here and click here. And for whatever reason, what is at the bottom copper is not showing up. So maybe let me just refresh my browser. Okay, maybe this one will fix the issue. That is like, oh my God, it's not here. Okay, I'm not sure what is.
While you figure that out, quick question from John, which by the way, you're doing a direct message. If you want to send it to everyone, you can change the setting, but it's all good. You're just saying or asking, can we see a 3D view of layers? Interesting question. We have a 3D viewer and you can see layers on the top and the bottom copper. But I don't think you can see mid layer. Like we don't have a kind of X-ray view that's like sandwiched, in 3D.
We don't have an extruded view, if you will.
Yeah, or like a sliced sectional view or anything. Yeah,
I would love to know more about what value you would get out of an extruded view. Like I tried to think about it. We've talked about it a couple times, but I couldn't quite nail the use case. You know what I'm saying?
Mhm.
Like I feel like you can get everything you need from the top down one-dimensional view. And for the cases that you can't, we got 3D. Wow. So just,
Okay. For this, for the sake of time, I actually prepared this board. I created this board prior to the bug that we experience live right now. This is basically it. This is how it looks like. The one that I just created a while ago. I created a via. Just clicking while the routing is active. You could traverse the bottom copper, and yeah, this is how it looks like. And maybe you're asking me, where are those pad that is like outside in here a while ago? Actually, there's a trick that I usually do when I design a board in Flux. Like, let me just click here, the D0, D1, D2, and D3, and I'm going to highlight them by clicking on here in the selector. And as you can see, they are inside here. See that? I'm going to highlight again. Those pads are inside the LED. That actually, like, I usually do that one so that I could clean up the board without actually like the pads are like in here or somewhere. Let's say if this is like located somewhere else like that, they are protruding here. It's good that you could have like, you could see the pad where it's the pad where you need to connect this sub layout once you consume it. But for me, personally, I usually put it aligned to where could be like here on the pad itself of the where it needs to be connected. I just put that in there, just align it, and then when I'm going to consume this board or the project, the air wire will appear here. And it, because that pad, it's located there. They are located here. You see that? The green out, highlighter in there. It's here. Also, and also another in here. So yeah, and then afterwards, you just actually have to publish this sub layout, just using, Control P or Command P, or you could just actually go here, publish changes, and just write down the note. I just routed this board. I just routed this sub layout, and then yeah, for anyone who's going to use this, project, yeah, they're going to receive this update that you just routed, or maybe if you have changed something on the trace or whatever, they're going to get that update. So yeah, so far there is like more about that cover everything about our our agenda for today. And next week, we're going to use this on a project.
Hey, gents, a question of a fairly basic nature, and that is that when you're generating a project, correct me if I'm wrong, you're using the schematic as the basis, and then the PCB follows the schematic. And here's the reason why I asked that question. If I'm looking at the PCB and I want to do troubleshooting, am I trying to make sure that there is a connection dot whenever there is a connection, and that anytime that I'm running over something, I assume there's not a connection, unless it is on a different layer? A long-winded way of me saying how to be able to do troubleshooting.
Yeah. Okay, so maybe Brooks could actually answer that one, because this is regarding about the what was the bidirectionality currently right now.
oh man, yeah, there's a lot here, but the first part of your question is easy to answer. Yep, you got to start on the schematic.
Okay.
This is how you sort of create your guardrails, your logic. You're saying, hey, abstractly, I want things to work this way. And then
Okay.
in the PCB, you say, okay, that was the abstraction. Now let's get real. How's it going to work in the real world? The second part of your question, I don't understand.
Yeah. It's hard for me to phrase, but I was trying to find out how to be able to do troubleshooting. So, for example, when he was drawing the lines and he was saying, oh, by the way, I want to be able to do a connection from one point to the next. There was a specific methodology that they used to verify that there was a connection, as opposed to lines that look like they're crossing over each other, but it's not actually a connection. So that's just a way I'm asking, how do I actually verify that I have a connection as opposed to not having a connection?
Oh, that's a real good question. I like it. And you're talking about a connection. You're talking about wires drawn between parts on the schematic, or you're talking about traces drawn between pads on the PCB?
I think it's more the latter. So you have a well-defined node that looks like a dot. That makes sense that if you're looking at my picture or my face, that where the cross is, if there's a dot there, that I'm actually making a connection. But if I don't have a node here at this point, I may have something crossing over. Does that really mean that it's actually making a connection?
Okay, fun. Yeah. Hey, this is a cool question. Also, say hi to the church bells in my neighborhood. So, to answer your question, the way that Flux thinks about it is that the only real connections made are the connections between those little dots that you see on PCB.
Okay.
But the reality is that if you draw copper over other copper and then you print that circuit board, congratulations, those coppers are now one copper.
Right.
So in the future, we need to do a better job of making sure that when you set up your guardrails and you say, I want my nets to work a certain way, we know what that means. And that means don't let me connect this to anything else, right? Don't let me make those mistakes. Those features are coming soon. Please bear with us, but they will be here. For now, please be careful and don't cross your copper.
Okay.
Don't cross the streams.
Do not cross the streams.
I think that brings up a really good question, though, which is when you were talking about that, I was thinking about cross probing, which is like, how do I get visibility into the schematic while looking at the layout? So say you have something, excuse me, selected in the layout. It's nice to also have that selected in the schematic. Brooks, what's up?
Pick me, teacher.
Yes.
You can do this today using the power of real-time collaboration in the browser by opening one window over here and having that on schematic, wait for it, and another window over here and have it be on PCB. Bow, bow, bow. Because of the power of real-time collaboration, the stuff that you do on this side will be happening over here and you'll get to see both at the same time.
That's awesome.
Pretty crazy.
Also works in the same tab. You know, if you just click PCB, select something, switch to schematic, you'll see it selected there. But yeah, you could have it in two tabs too.
Solid.
So I have a quick question on
Go for it, Dave.
when you're on the top layer, it's all red. Does it automatically change to the blue when it goes to the second layer or the third layer, so that you know you're a layer deep?
Yes.
Okay, and then my second question would be, is there a way I could put a pad on, like, say, for instance, that blue line, and then put one on the red line and use those as test points to test the voltages? Yes, I can. Okay, good.
Yeah, you can work on any layer like you are, you know, on the red layer on top copper. You could route on middle layers, on the bottom layers. And then, you know, the bottom left there, the layer view controller there is your guide. So you can see when he clicks on a layer, that's actually activating that layer.
Okay, all right, I get you.
Yeah. And you can also hide layers to make it a little bit easier to see what you're doing.
we allow the creation of random pads. Like if that's what you want to do, we'll just let you do it, right? You can like right click over there on their layout. Oh, there's your add pad. Boom. You can just make a pad and connect some copper to it. You can also add a terminal if you want to do it properly. You can add a terminal on the schematic side and then like actually route to or wire it up, and it'll be a part of a net. And then you'll know with air wires, hey, but yeah, see, exactly, boom. So when you make a terminal on schematic, we create a pad for you because that's what a terminal is, right? It's a pad. And so now, look, there's an air wire. You know what net it's supposed to be a part of, and you can properly draw traces to it. Boom.
If you create a pad in the layout, does it then, just a generic pad, not a terminal in the layout, would that then backfill to the schematic if you connect it to the net?
We're about to find out.
No, it's just actually a copper. It doesn't create any element on the schematic. If you
do you remember if that was intentional, Jarman? I feel like that is an unintentional situation.
Yeah, not intentional. Yeah.
Okay, that's unintentional. So just so that you guys know like where we're at, we imagine a future that is highly bidirectional. And we have done some things to enable this future to exist. Some things we have clearly not done well. Some things we haven't done at all. For instance, you may have noticed you can't even track parts from the library onto PCB. Why do we even show you the library? I don't know. Don't worry about it. So there's like not that kind of bidirectionality. And I think in this particular case, that's a mistake on our part. The best way to use Flux right now is to like make your decisions about what you want to exist on the schematic side first, and then on the PCB, make decisions about where those things should be placed in real space. And then down the line, we'll allow you to make more decisions on PCB first. Sort of not yet, though. We still think this is better than some of the competitors, though, by the way, where you have to like create a schematic and then like publish to PCB, and then like your shit can get out of sync and stuff. Like, what's going on with that, right? Like, at least we have a better way that they talk to.
Yep, totally agree. And just quick time check. So we're at 1:07 p.m. PST. So anybody who had to leave or has a meeting or something like that, feel free to jet. And those who want to stick around, ask questions, hang out, let us know what you're working on. Feel free to hang out. I'm curious if anybody worked on the demo or tried to complete the demo, had any questions, from last week or from what you saw today. Or it can be unrelated and more about your own projects and area that you might got stuck, and anything's fair game. Ooh, John's got a question. What is the state of the art on automatic optimized parts layout? Meaning that you can actually like go from schematic. Can you tell me more about that? Like automatically place it on a PCB and have it all wired up, kind of like auto layouting, like
auto routing.
Auto routing.
Yeah, I think he's asking about the auto placement rather than specifically auto layouting. So basically, I'm imagining here he's trying to ask. So basically, depending on the position of the pads or components of the schematic, that you kind of sort of extrapolate where would that be on the PCB and kind of try to put them together based on how they're connected on the schematic or some of those lines. I know that we've done a few experiments on that, but they're not yet sort of ready for the prime time. I don't know, Jarwin, if you have any more details. I know you've tested it at some point, but yeah, we haven't really started.
Yeah, regarding about if I'm not sure if if I'm going to answer this one correctly. So if you remember on the sub layout that I created, those pad, the connections to the outside world, should I say, that is like I keep them on the on the pad itself, like they are aligned. You can see the letter the pad D, it's there. Let's say here, what is that? It's here. What is that? D3. Yeah, it's here. D3. I hide them in here. And as you can see, this sub layout is being used on this project. Let me go here in the schematic. See here, this is the sub layout, of this here. Okay. Now I just actually tested and dropped a resistor R1 and connect it to D3. There's a connection to that P1 of the resistor to D3. Now, if I go to the PCB, there's an air wire that is like pointing to that exact location, even though I could literally connect. I should, or maybe I could, I could connect the wire, except only in here. I should be able to do it here, in here, in here, because it's a part of a net. But currently in Flux, where's the pad is located, that's where you need to connect. As you can see, the air wire doesn't actually like thinks that you could do it in here also because it's a part of a net, but that's not the case. You have to connect that R1 to there. I'm not sure if that's the question, so totally maybe I'm wrong.
I think he's asking more about like the placement of parts, and state of art is like there's still a lot of room to go. Our vision is to do as much as we can automatically and at least give you a head start on where the parts should be. So right now, even we use the information from the schematic to kind of like semi-intelligently group parts when they're placed onto the PCB, which is already a step in the right direction. A lot of tools just like line them up at the top, or stack them all in the same like 0, 0 location. So we're trying to do some intelligent things there, but there's a ways to go. Like I think we want to move towards more like parametric design where you're saying, okay, I know I have a plug that's going to be at this location. These are my kind of rigid constraints. I have a standoff here and in my enclosure. And so you might have a user like indicate, these are my hard constraints and like solve the solution for me as I put in parts, in my schematic. And then you get more into like the auto layouting territory. But first we need to build the bare bones, and then we can use the data to start doing more automations, automate all the kind of mundane work.
Yep. Yeah, there's another question from Brian, which is like very interesting. And I guess we stumbled upon this particular question, Brooks. So just to actually like put it in context in here, I have a resistor R2 connected to the G terminal here, the G pin, okay? And if you go to the PCB, this is the connection represented by it. Okay, let me just,
Did you read the question real quick, just so we have context?
Yeah, in your current example, a top layer is red and bottom layer shown in blue. The circular note, I guess that is the dot, imply connection between the layers. If I have more layer, how do I verify what nodes connect to what layer? This is exactly this one in here, which is like the air wire is pointing me to this red pad, which is like located on the top copper. I guess the question was like, is there any verification, that a node is like needs to traverse a layer in order for you to create a connection? Because if I do it like this, I'm on the bottom copper now, it's blue, I cannot just connect in there because it's on this different layer. You have to use a via. I guess that is like, something that we stumbled upon before. Brooks, if you can speak a little bit about that, like the air wires is like not showing an indication that is like you need to traverse a layer to connect to that.
Yeah, I think Brooks had to head out, but yeah, you're correct. You need to know that you're routing to another layer and create the via, like Jarvan said.
Yeah. Yeah. So if I have more layers, how do I verify what nodes connect to what layer? So yeah, that is like something that we're still thinking on how to solve that, because literally, if you are not really like have any you don't have any experience working on PCB on other tools, this is like not really straightforward, most especially for beginners. They're going to just click here. Oh, why is it that I cannot click here? Because it's a different color. You need to use the context menu and then go top copper, and there you go. Okay, then click on it. So yeah, the air wire doesn't show, the air wire, the wire. Yeah, I mean the line doesn't show or tell anything about, you need to traverse on something. I hope that answered the question from Brian.
It's a good question.
Yeah, definitely.
You answered it well. I mean, at the end of the day, I'll just probably have to limit my initial PC board design to just a couple of layers to eliminate or at least reduce the possibility of unintended layer connections.
Yeah, I will say that has been difficult for people, especially at like beginning, maybe designing their first PCB. Some people have been missing that they need to change. Our default is a 4-layer board, so you need to make sure you change that to a 2-layer. 2 layers is pretty good for like most kind of simpler projects. You can do that by clicking on layout and then going to the object specific rules, changing your stack up. There you go. And then you say 2-layer or 4-layer. Yeah. So that's how you change the number of layers.
Yeah, that's going to be helpful. And or really quickly, whenever you all engage different rules, or let me ask this again, when do you have to refresh? Whenever you engage different rules, or is there some specific time where you say, oh, by the way, I need to go ahead and just refresh, to update?
That is a great question.
Yeah, you don't really need to refresh your browser. It's just that we're still working hard to actually like improve the performance of the app, because currently right now you would see like, as we stumbled upon a while ago, the copper didn't actually like appeared on the canvas, even though I'm sure that I already click on it, etc. And that's when I actually like, okay, maybe I just need to refresh my browser. The app is like totally affected by the performance currently right now. But yeah, we're working hard to actually like, you don't need to refresh your browser. So yeah, I experienced before, if I'm working on a simple project like a very basic, maybe like 20 parts voltage regulator, I could actually literally design it without refreshing the board. But as you scale down as you scale up the number of parts, yeah, literally the app is like affected. That's why sometimes, I have the mannerism to actually like, okay, maybe I need to refresh my browser every time I encounter weird scenario. That's where I'm going to refresh the browser. But the end goal is like every time you add a rule, you move something, it should always like, do it live, in your screen. You don't need to refresh. It happens right away. Whatever you do on the schematic, it should appear on the PCB, side by side.
Thanks a lot.
Yeah.
I have another question, if I can, if we can go back to last week.
Yeah.
In the library, you picked the parts like the lead 5 and the resistor. How do I know which one to pick?
Good
I
question.
guess there's a boatload of resistors, there's a boatload of caps, there's
Yeah,
a
so yeah,
ton of
that's
LEDs in there.
yeah, because the library is like, that's where everything that is like created by community will going to appear. Sometimes people are like just trying out and testing Flux, and sometimes they're just going to publish a part, and literally if it's a resistor, yeah, it would be on the list in here. So I suggest, just use the hashtag. Remember this hashtag here, generic hyphen part template. And this is where I put all of the, my parts that I created that I usually use most of the time. So yeah, everything it's already in here. But in terms of, the trust that let's say, for example, you type in resistor and then, oh, what kind of resistor or which resistor here I'm going to use. Sometimes your bet would be like the number of usage, like for this one, the fixed resistor is created by Lance, but yeah, it's just a generic, it doesn't actually like tells you about, oh, what is the package size or whatever, you could actually like just look at the usage count. If it's like higher, that means to say, there's a lot of people using that part. And then if you want to be like go and very specific, I created this, naming lingo, like if you need the resistor, just type in R and then space. And then what is the package code? Do you need 0402? Just type in 0402. And then that's it. It's always on the top. That's my name. So if you need like a resistor that is like size 0805, and that is a resistor that has the package, the footprint size 0805. What if you want a capacitor? Just type in C. You want a 0402, C space 0402, and that's it. This part that I created contains a simulation model. So basically, you can use it, and it could be your circuit can be simulated, and it has a footprint also and a 3D model. Your best guess would be like, yeah, that one. So if you need like, for example, I need a circularly polarized capacitor. Just type in CP, okay? And then the international code, if you need the tantalum, so it's like EIA, and I have two in here. There's like the most common tantalum that I usually use. Hopefully that is like make sense.
Yeah, it does.
And just to add a more context, I don't know what if it's helpful or not, but I'll say it anyways. So when Jarwin was referring to the package or the size, that basically tells how big the footprint and how big the resistor that you're going to be soldering on that footprint is. Just kind of for a reference. So basically, when you say, for example, it says 1206 or 0805, that means that it's 0 point something mils in one direction, and then on the y direction. So if you want to solder by hand, something around 1206 is usually it's big and it's kind of easy to solder. If you're going to do it by hand, you can probably solder also as well like a 0805. It's doable. If you start getting smaller, then it gets, you're going to be able to cram more into a small space, but it gets harder and harder to solder by hand. So it's just kind of a sort of a frame of reference if you want to get started. So what you might want to choose depending on if you're going to be soldering yourself or if you're going to be asking a fab manufacturer to do it for you.
Thank you.
Yeah, and I just actually did what yeah, sorry, go ahead.
I said you can definitely see the size there, the size difference between the R3 and the R4.
Yep.
Yeah, I actually did what while Nico is talking, I just dragged the resistor R0402 that is like, in matrix that is like 1005. This is like the, the standard nomenclature of packages in terms of, these basic parts like resistor, capacitor. So as you can see, this is 0402 and this one is like 0603. So it's much more bigger, If you need a much bigger resistor, maybe you need like higher power ratings. Yeah. And yeah.
Thank you.
Yep. One of the biggest things is just make sure you use parts that have a footprint. I think that's like a common challenge. I forget who it was. So somebody's finished their circuit and they didn't have, a couple parts that had footprints, and so they had to replace those parts, which is kind of a pain in the butt. So yeah, just look for that icon on the left there. Looks like a little box.
Yeah, this one here, this means that this part contains footprint. And a piece of suggestion, I do this one every time I work something on Flux. So every time I drag a component or a part to my schematic diagram, I usually flip over, or I mean move over to the PCB, and then just to verify, okay, here is a footprint. Whatever you add, or every time you add a part to the schematic diagram, go to the PCB to confirm if there's really like a footprint. You could actually do it like this. Just click on the parts that you just added to the canvas, like this R3, select on it, then move to the PCB. You're going to see where's that R3. You can see it's here. It's actually like it's what would you call that one? It's outlined with green. So that means to say, that one is as a footprint. As you can see, also the free view shows like this one has a 3D model. That one here. If we move to the 3D viewer, we could actually see that R3 has a 3D model. As you can see here, I'm going to just see that R3. So yeah, so you could see what how large your board would be, or in terms of the total area or the height of a certain component. Yeah, you can do that one. Yeah.
That's cool.
Yeah, we'll actually show you, I think next session, how to import a 3D model, and get some other assets in there. I think you had an enclosure design, right, Jarwin?
Yeah, I'm trying to actually load the that project, but yeah, it might take a couple of seconds to load. But yeah, let's see, just to make some excitement in here. So literally, we're going to build this one here. It's the 8x8, so it's composed of 64 LEDs that is like driven by the Max 7219 IC. So if you go to the PCB, we could see actually like how it looks like in here. Hopefully this one will actually like load, because I actually like design the, what do you call that one, the where I'm going to enclose all of these LEDs, so it's just like this. See that those are the LED in there. And if I could actually like disable the model, that I could see how my board looks like. Wait up, let me just I'm just going to pull out the model so that we could see how it looks like in here. So yeah, this is like the board, and those are the LEDs, 64 LEDs, and the main driving chip is here at the bottom.
Oh, that's cool.
Yeah. Yeah, we're going to tackle this one on the next session. How could you literally use a 3D model, import it here in Flux, so that you could actually see, okay, this is my enclosure, let me see if, I could fit this board that I'm trying to design here in Flux, just to verify size. You can do that one already in here, as you can see. Yeah, this is perfectly the same size. So I'm going to pull it down again. So as you can see here, they are the same size. But yeah, the texture, this one is not metal. It's something showing that it made up of metal, but no, it's just 3D. You could 3D printed this one, and you could pour, like acrylic or something here, just to diffuse the, the LED. And literally, you could scale this up like 1,000 pieces, and yeah, you have a big LED, monitor. That
Yeah, that would be pretty cool if it was polished aluminum. That would be pretty bright.
yeah.
That's cool. I'll have to play around with it some more over the weekend.
Yeah. If you get stuck or anything, feel free to reach out on Slack. We're there to help you out. We can jump into your document if you share it and, make suggestions and whatnot.
Yeah, and also, if you're going to need some help and you're going to share the project link, make sure that the permission is not set to private, because we have changed something a couple of days ago, wherein every time you create a project, it's set to private. It's set to private. So if you're going to send that link to maybe like Lance, me, or Nico, we will not be able to access it. We will not be able to view it. So just make sure that the permission is set to anyone can comment first, and then send over the link. So yeah, we could unblock you with your project.
Okay.
Cool. Any other questions?
You put a lot of thought into this software, I'll tell you that.
Making
Good to hear
progress
that.
one day at a time.
Yeah.
Well, cool. Maybe we can wrap up. And thanks for joining us. Like I said, we're pretty active on our Slack. Hopefully everyone should have an invite to that. If not, we can put a little link here. But that's a good way to stay in touch between sessions. And like I said, if you're working on your own project and you've wanted to create a PCB, we are willing to pay for your first batch. And we loved your thoughts, your feedback, finding bugs. All of this is really helpful for us. So appreciate the patience and the time. Cool. Well, I'll see you next week.
Is there a way to access this chat? Like, if you put any links in it when you are online?
Yeah. Do you want me to? I can just post a link to our Slack.
Yeah, Nico just did it.
I just did.
Okay.